Hello, thank you for those that have joined today for our webinar. We'll be starting in the next couple of minutes. Thank you everyone for joining today. We really appreciate you all taking the time to join us for this webinar as we introduce the new MX2502 HOBO underwater PAR data logger. Used to measure photosynthetically active radiation, we appreciate your time in joining as we talk more about the principles of our data logger, as well as the light measurements itself. As we start today, I'd like to introduce our panelists that we will have available during this webinar. Starting off with myself, my name is Kristen Minish. I am a product manager here at Lycor. I have 15 years of experience with HOBO and Lycor instrumentation and currently focus on our HOBO products serving our water resource management and monitoring needs. Today, I'll be joined by two other panelists who will be presenting. We'll begin with Elizabeth Gordon, a senior technical support scientist with Lycor. Elizabeth brings over 15 years of experience focusing on plant physiology, light, and leaf area measurements. In addition to Elizabeth, we are also joined by Mamadou Ba. He is with our product management team here at HOBO with over 15 years of experience in their data loggers and instrumentation. His primary focus is on our HOBO connected products serving environmental research and agricultural applications. As we go through the webinar today, we do encourage you to ask questions. Please feel free to submit them through the Q&A box that you see within the webinar itself. It's located at the upper right-hand corner of your screen. We will answer questions throughout the presentation, and we'll also be reserving time at the end of the webinar to answer any additional questions that have come through. In addition, we'll be following up over the next day with a recording to this webinar and to answer any further questions that you may have after the presentation today. A bit of an introduction to HOBO, who is hosting this webinar. HOBO is now part of the Lycor family. They bring their trusted experience in data logging measurements in aquatic, terrestrial, and indoor applications to the Lycor product family. Their data loggers have been used in a variety of different applications in some of the harshest environments to help customers measure and understand the environment that they're working in. Coupling this with the Lycor family, Lycor has been built on light measurement. We've been building light sensors since the early 1970s and have used the light sensor technology as a basis to our greenhouse gas measurement technology, which we're now a global leader in. We are both supported by a global network of partners and channel resources to be able to assist you no matter where your research takes you within the world. In today's webinar, we'll be covering a few different topics. We'll start off by going through the principles of photosynthetically active radiation and underwater light measurements, and talk about some of the applications where you can take these measurements in below water surfaces. From there, we'll move into a demonstration with the MX2502 data logger so that you can see how it works in real time. Again, feel free to submit your questions throughout the presentation today. We'll take time to be able to answer those throughout the presentation as well as at the end of the webinar. With that, I'll hand it over to Elizabeth.
Thank you, Kristen. I appreciate you providing that introduction. I'm going to go ahead and turn my camera off, but we are here, and so if you do have any questions, we would really like you to ask them in the Q&A box. As Kristen said, it will make it a little bit easier for us to keep track of those. Okay, so The first thing we're going to do when we talk about this brand new data logger is talk about the principles and the science behind it. Because, of course, you can log any amount of data, but if that data is not good because you don't have a good foundation, you end up logging junk, and nobody has time for that. So we're going to talk about some principles of photosynthetically active radiation and underwater light measurement. As a reminder, let's talk about what light is. So light is something that's very easy for most people to detect, but it's a little bit harder to measure. It's a little bit harder to quantify because there's different ways to look at it. So we can talk about radiation in general. That's energy that moves in electromagnetic waves. So that's everything from the light that we see coming from the sun to the microwaves that heat up your lunch, and also things that can cause major health issues if we're talking about that kind of radiation. The radiant flux is the amount of radiation from a source, and the irradiance is the amount of irradiation per unit area. And I'm mentioning these because when we talk about underwater light measurement, then there's a couple of different things we tend to focus on. We are specifically looking at the visible light spectrum, which is a very small section of these radiation waves. That's the standard rainbow that we're all familiar with. Roy G. Biv, or technically it's Biv Gior, if you go in terms of the radioactive wavelengths. Each color has a different wavelength, and then that is that visible light. Within that visible light that we see, there is a slightly smaller section of light that plants, algae, and cyanobacteria see and use. All photosynthetic organisms, which includes plants, algae, and cyanobacteria, have pigments that absorb different wavelengths of light. And different pigments have different functions. So chlorophyll A, chlorophyll B, they absorb light and they convert it to energy in the form of photosynthesis. Other pigments are things like carotenoids, the thing that makes carrots yellow, anthocyanins, the thing that makes blueberries blue. If you hear people talk about polyphenols and flavonols and things like that when they're talking about nutrition, those are plant pigments. And so they give colors as we see them, but their function is to absorb light or help the plant do different things with that light. The light that a plant or cyanobacteria or algae reflects is the color that we see. So we see green plants, that means that they reflect a lot of green wavelengths of light. Once those light particles are brought into the leaf and they are processed through by those pigments, then we use that for photosynthetic energy with the chlorophyll molecules. So that then goes into what's called the light reactions of photosynthesis, which generate two of the important compounds for the carbon reactions of photosynthesis. I won't get into the plant physiology, even though I am a plant physiologist, but just so you know, this is why it matters. And we tend to talk about light that plants use in a couple of different ways. You'll see people refer to PAR. So that's photosynthetically active radiation. That is the 400 to 700 nanometer of light range. Within that range, the number of photons is called ppfd, photosynthetic photon flux density. But you'll see everyone, including us, use ppfd and PAR somewhat interchangeably. Technically, if I were to say, oh, the sun is 2000 PAR, I mean that it's 2000 ppfd in the PAR range. but everybody does this. So I'm going to use both of them through the course of my discussion. But if I say PPFD or PAR, I am talking about light that plants, cyanobacteria, and algae can use to create energy and then drive growth rate, yield, and development. If we're going to be measuring PPFD or PAR, which we are, we want to make sure that we have a plant or a sensor with a flat response across that range and a sharp cutoff outside that range. Otherwise, we could over or underestimate PPFD in the different segments of the PAR range, and that could lead to incorrect conclusions. So you see that I've got a graph of the typical plant response and the ideal sensor response. And then below, I've got a measurement of how the LI-190R, which was the basis for the LI-192, they work in exactly the same way, just a different housing to them. And you can see that we neither over nor underestimate PPFD in the different PAR ranges. That is not true for all of the various sensors available. So, and you might think, well, why am I looking at PPFD? Why am I looking at PAR? Why can't I just look at lux? If you're thinking about lux, which is another way to measure light, you would have to check and see what its wavelengths were. Because again, if someone says, I'm measuring watts per meter squared, I'm measuring lux, what are the active wavelengths of that sensor? Are you measuring outside of the range that plants can use? Or are you not measuring the entire range that plants can use? So looking at just foot candles or lux or lumens or watts, you know, the important thing there is not just the units that we're using, but also the wavelengths that we're measuring. And so I see growth lights at the home improvement stores sometimes, and sometimes they don't say anything about, they say that it's a plant growth light, but it doesn't actually tell me what the active wavelengths of that growth light are. I'm not buying that. I want to know if the active wavelengths provided by that so-called growth light are actually going to be useful for growing my plants. This is a plant physiology problem. I'm not sure everybody worries about this, but I do. So let's talk about some challenges in measuring PAR or PPFD below the water surface. So I've mentioned that there can be a little bit of a challenge in measuring it in general in terms of making sure that your sensor is actually measuring the wavelengths that you want it to. It's not over or underestimating it. Once we add water, then everything gets a little bit more complicated. One of the things that we do need to make sure of is that our sensor is what's called cosine corrected. And this means that the light is still accurately measured when the light source is at an angle from the eye or the diffuser of the sensor. Most light is a combination of direct and diffuse radiation, especially underwater. The sun is not always directly overhead, obviously, or your LEDs that you're growing your whatever your tank with are not always directly overhead for every part of the tank. So we need to be able to compensate for direct and diffuse light without doing a cosine correction. Light that is received as primarily diffuse radiation, sort of at an angle, could be underestimated. Light that's received as direct radiation could be overestimated, especially if there are reflections present, because that can cause the particles of light to essentially be counted twice without the cosine correction. So the LI-192 in the MX2502 has cosine correction. The other aspect that it has is a wiper, because when we're talking about underwater measurements, we have to consider biofouling. Things like to land on other things, and the number of barnacles that I have seen on LI 192s that have come back for calibration is not small. So sometimes our technicians do chip barnacles off of instruments when they are calibrating them. That's always entertaining. But the benefit of using the LI 192 in the MX 2502 is that we can use a wiper to keep the sensor window clear, and that means that the cosine correction works as well as possible. Without a wiper and taking care of biofouling, then the cosine correction may not work as well. The other thing I'll mention is that it's a very rugged housing. These are made of brass, essentially, and so they're able to withstand pressures and depths that terrestrial sensors would not like at all. If you tried to use a terrestrial PPFD sensor, it might work once and then never again, which is not ideal. We can also use it in air or in water. All LI 192s are calibrated so that you can have an in air or in water multiplier, so you can check it above the water column and then lower it down into the water column as needed for deployment or mounting. So all sensors are calibrated. Not all sensors that are available from other manufacturers are calibrated. And if we're not calibrating the sensor, we're right back to what was that growth light at the home improvement store actually measuring. We don't want an uncalibrated sensor. We might as well just be picking a number out of the sky with a uncalibrated sensor. No puns about the sun intended. But I'll go with the pun anyway. So let's talk a little bit more about why underwater PAR PPFD measurements matter. So we've talked about what they are. We've talked about why the LI 192 and specifically in the deployment of the 2502 is useful. But why would I want to look at PAR? I already mentioned that this is how plants use light. Okay, but there's other ways for me to understand ecosystem monitoring. Why don't I just use a Secchi disk? I mean, I'll just put it down there and it'll be fine. It is true that Secchi disk can provide information on water column turbidity, light extinction depth, but it doesn't tell you the quality of that light in the water column. And the human eye is not particularly good at being a calibrated light sensor, mainly because we have pupils. So we can say, wow, this light seems really bright. I'm in an office right now doing this presentation, and the light seems perfectly bright for me. But if I were to get out an LI 192 and measure it, I would find that probably there was almost no photosynthetically active radiation present in this room. So I could say the light is very bright, but it wouldn't tell me anything, and that wouldn't be something that would help my plants, my cyanobacteria, my algae grow. So just using a Secchi disk would help us with light extinction depth, but it doesn't tell us the information about the quality of light. It also can't provide information. It also can be subject to human error due to reflections or differences in eyesight. I think we've all been in a situation where someone says, I can see that, and someone says, no, I'm not sure what you're talking about. So if we have different people using the Secchi disk, then different people could say, yes, extinction occurred at this depth, and others say, no, it was fine a little bit deeper. The third thing that Secchi disk can't do is provide information on upwelling versus downwelling radiation. So now we need to explain what that is. As I mentioned, phytoplankton, algae, aquatic plants, they all use photosynthetically active radiation, and these organisms are often partially illuminated by reflections from particles suspended in the water below them, or if the water column is shallow enough, they could have reflections from the bottom surface, sand, rocks, unfortunately trash, things like that. So we need to be able to characterize that upwelling and downwelling radiation, because the photosynthetic organisms can use the upwelling and downwelling radiation. So if we just look at the light from above and we don't consider the light that might be coming from below, then we can over or underestimate the behavior. So we do need to consider measuring both downwelling and upwelling PPFD. The other aspect of why we would want to use a light sensor and a logger to measure things is getting daily light integral. So again, the amount of light received in any given 24-hour period cannot easily be extrapolated from instantaneous measurements. And this makes sense. I cannot say, well, the light is this now, so it must be that forever. We know that that's not how it works. Even in an indoor growth situation where the light goes on and goes off, you might still have some changes based on water temperature, turbidity, movement of things in your growth tank, whatever it is. So a daily light integral calculates the total amount of light received from in that particular point for an entire day. And in that case, we report the total number of moles of light of photons per day, rather than looking at per second, because it's a lot. So we end up with moles of light. So that is another one of the things that the LI-192 and the MX-2502 can measure. So now let's talk about just a few real-world applications for underwater PAR or PPFD data in freshwater and marine environments. This is just a very short précis of some of the research that could be used. I went to Google Scholar and I looked at some papers and I decided which ones would work best for this particular discussion. But let's talk about the Arctic. So a particular group wanted to know about upwelling and downwelling PPFD under ice. So not just looking at light in general, but light after it went through the ice layer and what that had, what effects that had under on the primary productivity of that particular area of West Greenland. Other researchers looked at photosynthetic phytoplankton productivity in the Arctic parts of the Black Sea. So they did a general research cruise, and one of the things they did was look at the photosynthetic light reactions or photosynthetic light availability. We could also do this in tidal environments or coral reefs. So Spartina alterniflora is a plant response. Is a plant, an aquatic plant, and they wanted to know about tidal inundation and whether that was going to affect anything. So they looked at not only incident PPFD, they also looked at chlorophyll fluorescence and tide level measurements using a HOBO water level sensor. Most of these papers that I'm mentioning are not just using the LI-192. They're using a lot of different things. It's just one of the things that we're looking at. But so I saw that HOBO water level sensor and I made sure to mention it. Another paper looked at sargassum accumulations and whether decaying sargassum would affect coral reef ecosystems. Maybe you're interested in habitat restoration. Eelgrass was transplanted in 3 different places in Santa Monica Bay in California and the USA, and they used light to monitor some of the factors that could have influenced transplant success. And another situation, a very turbid lake had some flocculation, some little particles that cause all the gunk in the lake to clump up. And that increased PPFD throughout the water column, and they were hoping that that would increase aquatic vegetation availability and habitat restoration for birds who might want to eat that aquatic vegetation. And then there's also aquaculture. So one particular paper looked at whether shrimp, commercially grown shrimp, were willing or able to be fed on macroalgae rather than commercial shrimp diets. And they did use the Li-192 to monitor the light level and see how the shrimp did. They also looked at the availability of light as it affected the ability of coral spat to grow and develop, and whether light might have allowed just the right level of light might have allowed the coral spat to grow without having outcompeting algae species. So they found that keeping the light at a very specific level was enough light for the coral spat, not so much light that the algae started to outcompete. So these are just a few of the ways that you can use the 2502 and how you might want to consider integrating it into your research program or your monitoring program. I'm going to hand over to Mamadou now to talk about the features and the specs. So I will stop sharing it for the moment. And Kristen, did we have any questions that I should answer?
Yes, we had one come in where they asked about downwelling and upwelling applications, and if you could describe briefly those applications and how the Li-192 can be used in those measurements.
Absolutely. So if we want to use the Li-192 in downwelling and upwelling measurements, we're actually going to need two. So we'll have one sensor pointing up and one sensor pointing down. And what that would allow us to do is look at parameterizing what is coming from different directions. Or if you're only interested in one or the other at a time, you could just flip the sensor. They're completely okay with being on their heads. So yes, so that would just allow you to parameterize what amount of light could my photosynthetic organisms be receiving from reflections lower in the water column, or versus what is coming in from above them.
Great, thanks, Elizabeth.
Yeah.
Now we'll hand it over to Mamadou.
Excellent. Thank you. Again, thank you, Elizabeth, for that excellent primer on power and underwater light measurement. What you've covered, you've covered the fundamentals and the real world challenges really well, and that context sets us up for the product discussion. So from here, I'll focus on the MX2502 itself, the key specification, how it works with HOBO Connect, and what you should expect in a day-to-day use. And then we'll wrap up with the overall Q&A. So as Elizabeth mentioned, the MX2502 combines the Li-192 underwater quantum sensor with a self-contained data logger. So we log power, temperature, and tilt, and I'll speak to those a little bit more. And it also uses water detect to confirm when the logger is actually submerged. So where it could be useful in tidal applications, for example. As Elizabeth mentioned earlier, the Li-192, the sensor itself allow you to measure in air and underwater power, but they're different coefficients. So if you have it set up to measure underwater light, but then it's above water, you will get the data may not make sense to you, for example. And what that water detect does is essentially add a QA and QC component to allow you to confirm the environment. Setup and data retrieval happens wirelessly with HOBO Connect. So like our other HOBO Connect, our other HOBO MX data loggers. And it is designed for long-term deployment with over 1 million data point and multi-year battery life, depending on how it's configured. So the content in this slide summarizes some of the core specification. So as I've already mentioned, the MX2502 measures PAR from the 400 to 700 nanometer range with a 5% typical accuracy. So really, the legacy of LICOR has pretty much been setting that standard when it comes to light measurement and accuracy. And the data logger itself supports logging rates from 1 second to 18 hours. Typical logging interval is probably 5 minutes or 15 minutes. So you always want to balance battery life with data density. It is rated IP68 to 30 meters. It uses a factory replaceable lithium battery, and again, communicates via Bluetooth. The form factor is compact enough for streams, reefs, aquaculture lines, and a multitude of other applications. So plenty of memory, super accurate device. The temperature sensor is accurate to 0.2 degrees C across the entire operating range. So when it comes to the parameters, they have been grouped intentionally. So you get those core measurement of PAR and temperature, but we've added the layer of these QA and QC parameters like tilt and water detect. So tilt is accurate to 5%. And again, water detect allows you to confirm whether or not your device is actually underwater. So all of these components help validate data quality and deployment conditions. And from those core parameters, we can derive accumulated PAR and daily light integral. Elizabeth already covered daily light integral and what it means, giving you a view of the previous day, that full 24-hour, what was the amount of light that was accumulated. What accumulated PAR does is actually throughout the day, it gives you an update. So the way to view it is daily light integral is a snapshot of the previous day. Accumulated PAR is throughout the day at every logging interval, how much light's been accumulating throughout the day. So that's the difference there. So these are used for restoration threshold and productivity analysis, as Elizabeth mentioned earlier. So on calibration, just to add to it, calibration, especially when you're working in research, having a calibrated device is fundamental to defensible PAR data. And this is where LICOR's legacy really matters. LICOR has been setting the standard for light measurement since the 1970s, so it's a long time. It's 50 years of experience. And the LI92 sensor used in this MX2502 built directly in that history. So each MX2502 is factory calibrated using LICOR's established procedures. It's a NIST standard, and we do recommend, especially in research application, that these devices are recalibrated every 2 years. What it does, this just ensures consistency across your deployment seasons and the various sites you may be using your devices. And really what it means for users is just you have the confidence that the changes in the data reflects the real environmental conditions and not sensor drift or anything like that. So really that calibration heritage is a key reason researchers trust LICOR sensors for long-term ecosystem studies. So to build on that, calibration is important. I would also say that deployment best practices as well matters. So this checklist, just highlights few essentials, right? Keeping the optical surface clean, preserve that cosine response, as Elizabeth mentioned earlier. It's always good practice to just verify live readings before submerging to help catch any potential setup issues. Tilt, again, viewing at your tilt once you have your setup, looking at the tilt measurement, the mounting stability, and if you use a wiper configuration as well. They all play a role in long-term data quality. So we're highlighting here a companion product from Zebratech, the Hydro Wiper. It is not a product that we do sell, but we do recommend it as a companion product for long-term deployment. We do have a bracket that you can get from us that will make it compatible, and ZebraTech, the ZebraTech Hydro Wiper is widely used in this type of application and fairly trusted. So just some troubleshooting and data quality guidance. So this is just to help you interpret some common patterns. So for example, some sudden tilt spike usually points to maybe consurges or a loose mount. So making sure that that device is mounted, is securely mounted is very critical. Some flat midday power often indicates fouling. And some unexpected changes are best interpreted alongside turbidity, tides, or weather data. So it is always good practice to compare the surface, those near bed loggers that you have with some surface data is always a simple way to validate some of the trends that you might be seeing. So just wanted to highlight some of the mounting options that we have. As I mentioned earlier, good data starts with good deployment. So we've made sure that the MX2502 supports several mounting options depending on the environment. As I mentioned a minute ago, we do have a clamp that you can get from us that makes it compatible with the Hydro Wiper. We also have this rebar plate, which is a pretty typical use, using a rebar just to make sure you can mount it near bed at the bottom of the floor, at the ocean floor, for example. So we have this bracket that can allow you to secure the data logger with or without the wiper, and just make sure that it is fully secure and well mounted. We also have this lowering frame that you can use. So you have a suspension ring that you can use on a buoy. You can put a weight just to make sure that it is fully submerged, and this will allow you to balance it and keep it vertical. We also given options. Again, they can be mounted with a wiper. This configuration, I'm just showing one data logger attached to it, but you could actually even mount 2 data loggers. So in a case, maybe you want to do downwelling and upwelling, for example, that allows you to mount 2 data loggers. But again, where fouling is a concern, all options are compatible with wipers again. But again, ultimately, the key here is a clean sensor means you get reliable data. All right, so obviously the MX2502 is a new device, but LICOR as a whole has a legacy of supporting underwater light measurement. So this table really is just a comparison to help clarify positioning. So how I would position this is that the MX2502 is designed for unattended long-term underwater logging, right? But there are instances where maybe you have a different need. So we do offer the LI 1500 and the LI 250A. Those I would say are better suited for real world or real-time profiling and spot measurement. So I would say, depending on the type of work you're doing, research study, or maybe you have your operation, you may use these tools together at different stages of a project. For example, when you're trying to select a site, maybe you just want to do quick instant profiling. There, the LI 1500 may be better suited for it. Or let's say you just want to do quick spot check and manual reads, and also do some instant profiling. Maybe the LI 250 may be better suited for that. So just to say that each tool has its place. Ultimately, if what you want to do is long-term deployment, the MX2502 is probably your better solution. But if you have other needs around profiling, I would urge you to reach out to us, to reach out to LICOR, and we can share the additional solutions we have for that. With that, I just wanted to quickly do a demo just to show the software and how it works. Maybe I'll check real quick. Kristen, should I move to the demo, or are there questions we want to tackle first?
We'll go ahead and do the demo, and then we'll go to the questions. We're getting lots of great questions in them, so we'll spend some time after this to go through those.
Excellent, excellent. So I'll just make sure I take a few minutes here, keep the content at the 45 minutes. So if you're familiar with HOBO, especially our Bluetooth devices that we've had now for well over a decade, we have a free app, HOBO Connect. And with a lot of our devices, they come out of the box ready. So essentially, you get them out of the box, you press a button or use a magnet to wake the logger from its deep sleep or idle mode, then it starts to broadcast that data. So these are just a couple devices that I have here around in my basement. But I have one of the underwater power right next by the window here. So as you can see, I just have it standing vertically. It's already giving me the power, temperature, and tilt. So if I select the device, give it a minute here. So this is a brand new device, just received yesterday. It hasn't been configured, so it will just tell you, it's in its default configuration. So as soon as we refer to this as the connected scene, as soon as I connect to the device, you see the additional parameters. You get DLI and accumulated power. So this is a brand new device. It's not launched. That's why there's been no accumulation. You're not seeing anything. So a couple of things that I just wanna highlight. That's useful. The default name is the serial number. It's always good to give it a meaningful name to you. If you have a multitude of devices, you can take advantage of this grouping where you can label devices with a specific group, and it can be easy to search and find the devices. From here, really, the default setting, if they work for you, 5-minute logging automatically gives you a sense of the logger capacity when the device starts or not. Generally, it is good to set it at a date and time. Let's say here, I could set it up to start at noon. From here, depending on your needs, you can automatically get started. I mean, in literally 5 minutes, you're up and running. No needs for programming. But a couple of things that I want to touch on, again, especially for long-term deployment, we have a neat feature that can double pretty much as a power saving feature. Earlier, I mentioned about some of the QA and QC parameters like water detect. With Bluetooth, when a device is underwater, water will absorb the Bluetooth signal. You cannot really communicate with a device, and Bluetooth communication does use a decent amount of power. So one neat feature here that we've added as a power savings mode is you could actually enable this feature and say, like, whenever you detect that the device is underwater, just disable Bluetooth, because probably well over half of the power use is the Bluetooth communication. So these are just a couple tricks you can use. Turning off Bluetooth when water is detected will extend the battery life of your device, for example. And we've also now added this capture location data. So it is off by default, but let's say if you have multiple devices in the field, or maybe you're part of a team and you really want to know where devices are deployed. So what this feature does, this location data, if you have it enabled, as you're deploying that data, where you configure that data, it will log that coordinate and give you just a sense. So as you probably reconciling your data, pulling it all back together, you can use that location data maybe to help localize where a specific device was used afterwards. One thing that I will touch on, so underwater power is enabled by default. As Elizabeth mentioned earlier, the sensor itself has different coefficient for underwater or in air. So if you wanted to use this device for whatever the reason may be for in-air application, couple things to note: you have to enable the in-air power, and also you want to make sure that the top of the sensor is dry, because you don't want to have water on the top of the sensor. You want to make sure that that sensor is dry and clean, and that will allow you to measure underwater power. That will allow you to measure in-air power. Goes without saying, if you're using it in air power application, it will still log that underwater power value, but it is not useful at that point, right? So you just want to make sure you only rely on that in-air power data. So those were just a couple of things I wanted to touch on. Again, all parameters or all parameters are enabled except for in-air power by default. You can choose to disable some parameters if you don't need them. And what it just does, it allows you to use that memory for the parameters that are important to you. And like all our MX devices, you have the option of getting it connected to our cloud platform, so that every time you offload that data, it can push it to the cloud, and you have a singular point where you can access all your data. So really, just that's all I wanted to touch on. So again, just to quickly summarize here, the MX 2502, really what it does, it brings research grade underwater power measurement into a simple, easy to deploy and the right form factor for long-term deployment. So with that, oh, sorry, I almost forgot about this. Probably some people are wondering about that. So this is the price list for this device. So the sensor itself, the data logger, the full complete data logger with the sensor integrated. The list price is $1,199. And below there, you can see the price for some of our accessories. So that bracket amount is $75. If you want to attach it to a rebar, the lowering frame, $199. And that clamp that makes it compatible with the Zebra Tech Wiper is $99. With that, we'll transition to Q&A.
Great. Thank you so much, Mamadou, for that overview and for that software demonstration. Wanted to spend some time going through a few of the questions that we've been receiving in. One of the questions for you, Mamadou, we have a question about the different light sensors that are offered by HOBO and Liquar, and they're curious, when should they choose the LI-192 or when should they choose a different light sensor for their work?
Sure. I mean, as Elizabeth, and feel free to augment Elizabeth, so if I think about some of our previous waterproof product we had either the UA or the MX-2200, right? Which really what it does is provide you lux. Now, there are tools out there that, claim that you can take, lux and extrapolate it and come up with par, but, really without getting an underwater power value that really lets you know, between that entire wavelength, really the type of what it means for example, in this situation for aquatic life, you are not really getting useful insight. So I would say it depends on what you need. If all you need is lux, just essentially what human eyes care about, then that could work. But anything related to aquatic life and ecosystem, I would say then what you need is the LI-92, for power measurement. We also have the global radiation sensors. So if you may be doing work around energy monitoring, let's say if you have a solar farm and things of that nature, they're probably what you want to use. Is our MX-2309 or the Li-200R to measure global solar radiation. Elizabeth, anything you want to add to that?
No, I think that's a good summation of it. It really depends on the question that you're asking and how much data you need. So that actually ties in, thank you, Mamadou. That ties in well to one of the questions that I saw, which was, what was the difference between turbidity measurement and PAR? And it's a matter of looking at not just the overall light availability or lack thereof if you have a very turbid water column, but also in that specific amount of light, what could the photosynthetic organisms be using? So just looking at lux might not tell you what the photosynthetic organisms could be using. So, yeah.
Great. Another question that came in, Elizabeth, I'll hand this one over to you. What does the calibration protocol look like for marine versus freshwater? Are there different calibration applicables to both?
Yes, so we just use in air and in water. And when we started testing the LI-192 back in the 1970s, I was not working for Lycor at that time, but we did a lot of work and we determined that the marine and freshwater calibration could be the same. So there's no need to change that. The other thing that we don't need to change, which some manufacturers of light sensors do, you have to change the calibration depending on your light source. Whether you're doing sun or LEDs or fluorescence or whatever, then you would have to change your calibration. You don't need to do that for the LI-192 because its response is so flat and so close to the specified ideal range that was developed by light researchers in the 1970s. Mamadou, if you don't mind, I'm just going to start rolling through some light questions because they're all tied to each other. So someone said, what happens if it rains? Do we need to use the in-water multiplier? No, we don't. It's just, if there's a little bit of rain on it, that's fine. But if we are going to be deployed in the water, then we would definitely want to use the in-water multiplier. And the water level sensor, the water sensor in the 2502 is not going to interpret a shower as being underwater. It's a little bit more sensitive than that. Let's see, what's another question related to this? How to choose and set the depth of the sensor, it really depends on the measurement that you're taking. People who work with me at Lycor know that my very favorite phrase and my very favorite way to answer questions is it depends, but it really does. So you'll need to look at that based on your particular question as terms of depth and setting that. You want it to be deep enough in the water column that it gets the measurement that you need, but where that measurement is really depends on your actual research question. Someone asked if the cosine correction was a function of the housing design. Yes, that's correct. The housing and the diffuser are what allow the cosine correction. It says, in the user manual, Lycor states that the 192 is not intended for prolonged use. So the reason that we do state that it's not intended for prolonged use is without something to take care of the biofouling and the barnacles, then you end up with some problems and you end up with bad data. Since we do have the option for that wiper, then that means that we can deploy them long term. Okay, how do you validate live readings on site? Honestly, we know what the sun is. The sun is what we usually use to validate readings, especially because we know that at solar noon, full sun is about 2,000 micromoles of light. So we just check that. You might also want to have a second sensor, just kind of put them next to each other. That's fine. It does generally need to be deployed vertically. Yes, you could technically deploy it sideways if you wanted to, but upwelling versus downwelling radiation is not going to be as helpful or as sideways radiation. Is the factory calibration longer or more expensive for an LI-192 because it's incorporated into the logger? We don't anticipate that. So what would happen is that you would send us the entire thing and then we would disassemble it and then put it all back together. We don't anticipate there being a change in the calibration time for the 192 as deployed in this as others. And I think that's all my light sensor questions. There's a couple of questions about the HOBO app and user replaceable batteries, and those are all Mamadou, but I think I got all my light sensor questions.
Sure. Thanks. Yeah, maybe I'll touch on some of those. So when it comes to the battery, so yeah, it is factory replaceable. But as I mentioned earlier, under just normal use, let's say you have it, logging once a minute all the time and things of that nature, and Bluetooth enabled, it'll last you about 3 years. But again, that power saving mode, I would say is a good option, as it will allow you to extend the battery life a minimum of 5 years. So right now it's 6 years, and that 6 years could even be longer, depending on how often you're logging data. But I would say ultimately, again, based on the better practices, just having to do that recalibration, which we highly recommend, by doing that recalibration at the same time, once we do that, as part of that service, we'll also replace the battery. I see a quick question here on why is the location required? It is not required, so it's an option on enabling the location. It's an option that is, we don't enable the location because it's not information that we want to track. But let's say, if a user wanted, just for simplicity, as they're going back through their data, to be able to know where was the serial number for this device was deployed, they can turn on that location at the time of configuration. So once you turn it on, after you configure it, when you export that data, if you go into your events tab, because we generally have 2 tabs, there is one for your data, and we have the events tab. If you go to that events tab, it will give you that information on the location. Any questions we may have missed, Kristen?
I think that covers it. Again, for all of the attendees, if you have additional questions, please do not hesitate to reach out in the chat. We are happy to answer those. In addition, we will be sending this recording later this week to you. If you have any questions that come up after you receive the recording, you'll be able to respond to that message as well, and one of the 3 of us will be able to respond to you in a timely manner. I'd like to thank both Mamadou and Elizabeth for their presentations today. This is really insightful and great to see the overview on the measurement principles as well as the new logger. So thank you both for your time in doing that. We will go ahead and end the webinar here within the next minute or so. But again, if you have any questions, please continue to submit those. We can answer those, or you can respond to the recording when you receive that. Thank you all for joining. Thank you for your time. As you see here, here's our websites for any additional resources. There's also other webinars that will be coming up, including getting your data logger ready for field season, and best practices for water level monitoring. Both of those will be given here within the coming weeks and will be great additional resources for researchers or monitoring groups who are preparing for their field seasons right now. Thank you all again. We appreciate your time today.